Bismillah, Assalamualaikum. This will be a simulation for the final exam of statics. This will be the third version where we have two previous recording for simulation of answering the final exam questions. Now, this different version is basically different sets of final exam questions from different semesters. So if you go through all, including this one, the three sample, you can see the different type of questions that can be asked, that can be given in the final exam. Let's take a look at the exam paper. So this is end of examination. It is for 3 hours. Statics, we have 4 questions for 6 pages. So let's take a look at the 4 pages, the 6 pages. Question number 1, we have this question here. So it asks for centroid and moment of inertia. Make sure you understand what the question asks. So this in particular, for example, figure 1 and figure 1 asking for the same, meaning based on the same diagram, the question actually is two different questions. One is asking for centroid, another one is moment of inertia. And this one is asking about moment of inertia for these composite areas. So that's question number 1. Question number 2, so we have to find the weight and support reaction. So this is relating to support reaction, so make sure you know how to do that. And then okay, B and C with regard to this diagram here. So of course this is also support reaction. We have to determine the reaction, etc. So same, just different is this is 2D and this is 3D. So support reaction question can come both in 2D and 3D in one exam, as we can see here. And then this is just an understanding question. Normally if you see the marks as something small here, normally it doesn't require calculation. It is to test whether you understand or not the concept. Now question number 3, we have a machine here. So this is regarding the machine. We need to find the force, so that's from machine. But also this is internal loading. So this question combines two different chapters. One is about machine, which is you have this clamping plier here, and another one is in internal loading at a particular cross section. So yeah, so this means that you have to answer part A first before you can answer part B, because you have to know the forces. Well, it depends, because if you cut here, then if you use just the left, then even if you do not have the answer for part A, you can still get the correct answer for part B. Okay, and then question 4, okay, we are given these two boxes. So this is most probably about friction, just by looking at the diagram. Let's see. So yeah, we have coefficient of static friction, etc. So this is involving equilibrium problem where static friction is there. And then we have the appendix where we might need to use for example, the moment of inertia equation perhaps. Right, so that's normally, so it will relate to the composite areas earlier, this one, right? So when we divide, we have these different shapes. Now looking at the marks, so question 4 is 25 marks, question 3 is 25 marks, question 2 is 25 marks, question 1 is 25 marks. So in terms of your planning, you can roughly divide the time given to 4 segment of time, right? So with 3 hours, if you divide by 4, each questions at most it should be solved within 45 minutes. Now we are 3:39, and let's consider that we have started at 3:30, and this several minutes normally is good just to have a glance through all the questions to know, okay, those are the questions, and you can strategize which question you want to solve first, right? Depending on different strategies, solve the easiest one first, for example, etc. Right? With that, let me take note. So starting from 3:30, so we should finish by 4:15, right? If you use maximum 45 minutes. So we have actually used 10 minutes, so 35 minutes left for question number 1. Now, normally if you have watched the previous simulation, I use the time as if this is in the final exam in itself, so that it's not just me solving problems, it is within the time limit as well. Alright, so we have used this 10 minutes for just to get a glance through, etc. Normally in the final exam you do not use until 10 minutes, maybe 5 minutes is enough, but this is because I'm talking to you as well, right? Okay, so Bismillah. So we will go question 1. So again, question 1 have 3 parts. If you look the marks, so make sure you want to get all the marks, right? But you can see the distribution, so this is important. Every single mark is important anyway, but in terms of the time, this may take longer than this one and this one, perhaps. Normally that should be the case. Okay, question number 1. Determine the centroid of the shaded area shown in this figure. State the answer as a coordinate. Alright, so let's take a look at the important points. So this is question 1A. So the final answer should be in coordinate, right? So meaning that what is x bar, y bar, right? That's the final answer. Clearly indicate which element and equation used. So basically, when you have something like this, now I noticed in the exam, in the actual exam, when the student submit the marks, the answer, some student actually use the integration, and yeah, that's how we should solve this question, meaning you use the integration, but some students use composite, right? So basically it is basically something like this. They consider this equal to a triangle minus this curve, something like that. Now the thing is, this can be used if you know this and you know this. For triangle, no problem, but this one, right? What is this curve? So some student get something from the table, but if you look at the table, make sure you understand what it is. For example, here, if we can see here, right? Okay, so all of these are 3 different curves: 1, 2, and 3, right? But this curve has its own name: semi-parabolic, x-parabolic, and parabolic. Now, if you have your own curve, just like we have just now, is it semi-parabolic, is it x-parabolic, or it's parabolic, or it's something else, right? So if it's something else, then you cannot use any of these 3, right? So make sure you understand that. So that is where I think many students actually get this wrong when they use composite. But one of the area for triangle, no problem, but for this one, you do not have, unless you have, because even if you want to use this one, it will still give you the right answer. But for this one, you still need to use integration as well, and might as well just solve the whole thing by using integration, right? Because you cannot just use any of this, because this curve is not parabolic, x-parabolic, or semi-parabolic. So make sure you understand that. Alright, going back to the question. Alright, so I'll delete this one. That's just explanation. We just use 4 minutes for explanation. Anyway, so we will okay, we'll do integration, but again, for integration you have 2 choices, right? One is using vertical element, one is using horizontal element. Now if you use now for this type of area, either way you have to have that minus, right? Because you have to limit, or 2 equation that govern the point, this point and this point, as well as this point and this point. Now what you have to decide early on is that you know that this one will have the x here, and you know this one will have the y here, right? And which means that if you choose this one, you will integrate with respect to the y. If you choose this one, you will integrate with respect to the x. Now make sure that whatever you want to choose, it is possible. For example, this equation on top here, right? We have y equal to 4x plus 2. This you can integrate with respect to dx, right? But if you want to integrate with respect to dy, you have to express it in term of x in term of y. So if you do this, you'll get what, y minus 2, and then you divide by 4, right? So either way you can do in this case, right? This one can be integrated with dx, this one can be integrated with respect to dy, no problem. But the other equation here, y equal to x cubed over 4 plus 2, you can integrate with respect to dx. But if you want to do this one, can you determine this one? Right? If you cannot, then this is not possible. So you have to use this one. You have to use this one. Because this one, if you select this element, you'll get stuck here because you cannot integrate this one. Right? This equation here. So make sure you know that from the beginning. Do not start straight away and calculate. Until then, you got stuck and you have wasted time. Alright? Okay, so we will use, with that in mind, so I'll just leave it here. We'll use using vertical element, right? Because the question say clearly indicates which element used, so we use vertical element. Even if the question do not say that, actually you have to indicate what you use, otherwise we cannot understand your calculation, because the calculation start with which element you choose. Alright, so is that in the case? So basically what happened is something like this, right? And if you use vertical elements, so basically what is you doing is you chop like this, and one of the element, if you select, it'll be the vertical element like this. So we have it here, right? So this one will be dx. So what is the height? So here, if we label this as 1, and if we label this as 2, right, in terms of the curve. So curve number 1 is described by this one. So let's say this is y1 and then y2, right? And of course in this case y1 will be x cubed over 4 plus 2, just taking from the question, and y2 is simply 4x plus 2. So here is y2 minus y1, right? So dA is y2 minus y1 dx, and then you can calculate this one. Okay, so we have the value, right? So we can calculate. So dA equal to y2 is up here, so 4x plus 2, and then minus y1, which is down there, x cubed over 4 plus 2, and then the whole thing dx actually. So if you resolve this one, you'll get 4x, there's nothing x here, so minus x cubed over 4. This 2 minus 2 cancel each other, right? So you'll get basically this one, right? Dx equal to 4x minus x cubed over 4. Now, okay, we haven't stated the equation, right? So what is the equation for what we're talking about here? Centroid. So the equation is x bar equal to integration of x with a sorry, what am I doing? dA, right? I already forgot it because it has been you know, the semester has ended for some time, so it's not that fresh. Normally in your exam you should be fresh because you just cover and you just revise. I'm doing this just without any preparation, so do expect some of the thing, it does take time for me to recall. But anyway, so this is the thing. So that's the equation, of course, for y bar equal to integration of y with dA over integration of dA. Right. Okay, another thing that we haven't described here is what is x wave and y wave, right? So if okay, let's use purple. So this coordinate is x wave, y wave. So where to put it? Okay, there's no position. So in this case, okay, x okay, we do not have enough space. So x wave is x basically, and y wave is y2 plus y1 over 2, right? Is the average. Now if you want to resolve this one, should be resolve it. So okay, my placement is, the positioning is problematic. Okay, so continuing here, continuing here. So y wave is, y2 is what? Y2 is up here, so 4x plus 2, and then plus with x cube over 4 plus 2, and then everything divided by 2. So what you have here is y wave is okay, so x cube over 4 plus 4x plus 4 divided by 2. So if we simplify further, y wave is x cube over 8 plus 2x plus 2. Okay, right, so we have, for the element, we have dA, we have x wave and y wave, and then we have the equation already. So let's solve for x bar first. So x bar equal to, so we have integration of x wave. X wave is what? X wave is ax, sorry, x wave is x, and then dA is 4x minus x cubed over 4. So 4x minus x cubed over 4 dx. 4x minus x cubed over 4. Alright, so divide by integration 4x minus x cubed over 4 dx. Now what is the limit? Because we chop like this, right? We chop like this, so the limit start from 0 until what is this? What's the question? Until 4, right? Until 4, 0 until 4. So going back here, zero to four. Alright, so simplify that. You have 4x square minus x to the power 4 over 4 dx, divide by integration 0 to 4, 4x minus x cube over 4 dx. Now, so integrating, so 4x cube over 3 minus x to the power 5 over 5 and 4, 20. So this is from 0 to 4. Oop. And then 4x square over 2 minus x to the power 4 over 16 from 0 to 4. So if you solve this, okay, I use so many space. So if you solve this, you get 4 cubed over 3 minus 4 to the power 5 over 20 4 over 2, 4 square minus 4 to the power 4 over 16. So if you calculate that one, 4 times 4 power of 3 divided by 3 minus 4 to the power of 5 divided by 20. So that's basically 512 over 15 on top, divide by 4 times 4 square divided by 2 minus 4 to the power of 4 divided by 16. divide by 16. Okay, 16. Okay, so if you solve this, you'll get 512 divided by 15, and then divide by 16. You get 32 over 15, or 2.133 meter, right? The unit is meter. X bar. Okay, so that's X bar. What about Y bar? So Y bar, of course, double check your calculation. Now Y bar, so integration of Y width is okay, this thing, right? Okay, I cannot memorize, so let's copy and paste here. So this is Y width, right? So sorry, so it will be, yeah, okay, let put it somewhere there. Okay, so it will be Y width, meaning x cube over 8 plus 2x plus 2, and then the A is what? 4x minus x cube over 4. 4x minus x cube over 4 dx. This whole thing divide by integration of 4x minus x cube over 4 dx. So the limit will be the same because we chop the meaning we divide the area into the same vertical element. So this is from 0 to 4, from 0 to 4. So we need to resolve this one first before we can integrate. So let's delete that. So if you okay, so if you do this, you get x x to the power 4 over 2, is it? This and this, 1 over 2 x to the power 4. Okay, and then the next one, minus x to the power 6, 8 times 4 is 32, right? 32. And then plus 8x square minus x to 4 over 2, and then plus 8x, what is going on, plus 8x minus x cube over 2. Okay, this whole thing is 0 to 4 dx over integration of 0 to 4 for x minus x cube over 4 dx. This is 4, right? Now looking at this, these two can cancel, right? These two, sorry, is there anything that can be cancelled? Oh, nothing, is it? X to the power 4, double check, x to the power 4. Okay, x to the power 4, and okay, yeah, this one, x to the power 4 over 2 and minus x to the power 4 over 2 can be cancelled. X power 6, x power 2, x power 1, x power 3. Alright, so if we integrate that one, so let's go, we are lacking of time now. So x to the power 7 over 32 times 7. 32 times 7 is 224. 32 times 7, 224. Alright, plus 8x cube over 3 plus x square over 2 minus x to the power 4 over 8. This is from 0 to 4. Divide by 4x square over 2 minus x to the power 4 over 16 from 0 to 4. and then we plug in, so 4 to the power of 7 over 2 to 4 plus 8 times 4 to the power of 3 over 3 plus 8 4 square over 2 minus x minus 4 to the power of 4 over 8 divided by 4 over 2 times 4 square minus 4 to the power of 4 over 16. So if you calculate this one, 4 to the power of 7 divided by 2 to 4 plus 8 times 4 to the power of 3 divided by 3 plus 8 times 4 square divided by 2 minus 4 times minus 4 power of 4 divided by 8. Okay, this is an odd number. 5, 7, 9, 2, 1. Okay, we have to double check this one, but we'll complete this one first. 4 divided by 2 times 4 square minus 4 power of 4 divided by 16. Yes, 16. This is the same as before. So 5, 7, 9, 2 divided by 20 divided by 16. Okay, now before that, is there any wrong mistake? Double check. Oh, I realize my mistake. There's negative here. Oh my goodness. So astaghfirullah, this negative should be here, right? Negative, positive, positive, negative. So negative will be here, then this will be different. Minus 4 power of 7 divided by 2 to 4 plus 8 times 4 power of 3 divided by 3 plus 8 times 4 square divided by 2 minus 4 power of 4 divided by 8. So you get 2720 divided by 21, and then this divided by 16, you get 8.8, or basically before that. 174021 or equal to 8.095 meter. Now to put in completion, so we have 2.133, so the answer is in terms of coordinate 2.133, 8.095 meter. So that's it there. Alright, that's question 1A. Mashallah, we take so much time. Okay, question 1B. Determine the moment of inertia about y-axis. So question 1B. We are running out of time. So again, we will do integration. So what is the equation? The equation is again the same idea with respect to the previous one, which is this one, meaning that which element you can use. So we will use vertical elements, right? So using vertical element, So it will be dx, this will be y2 minus y1. So the equation that we will be using is a moment of inertia about y is integration of x square dA, right? So we need dA. So dA is y2 minus y1 dx. So dA is, so y2 above is 4x plus 2, and then minus x cubed over 4 plus 2. So dA equal to 4x minus x cubed over 4. So bringing it down here, of course the limit will be the same because we chop the areas the same as part A, so 0 to 4. So this will equal to integration 0 to 4 x square 4x minus x cube over 4 dx. Oh sorry, this is dx is missing. What is this? So dx is missing. Okay, so integration from 0 to 4, 4x cube minus x to the power 5 over 4 dx. So this will be 4x to the power 4 divided by 4 minus x to the power 6 divided by 24 from 0 to 4, and then you get you plug in the number, right? 4 times 4 to the power 4 over 4 minus 4 to the power 6 over 24. 4 to the power 4 minus 4 to the power 6 divided by 24. You get 256 over 3, or in other words 85.33 meter to the power 4. That's the answer. Alright, so question 1c. So let's take a look at question 1c. Determine moment of inertia of the shaded area. So we have combination of shapes, so you have to divide and then solve, right? So let's do this. So based on that, this is question 1c. Now we are approaching 4:15 because just now we said 4:15 should finish 45 minutes, the first 45 minutes. But of course it's not like that, meaning that if you're struggling and you're not nowhere yet and you see the time is almost up, shift to another question. Maybe that question is too difficult for whatever reason for you, and if you stuck there and then you do not solve other question, you might be losing marks you can get elsewhere. But for this one, let's see if you can use 5 minutes, right? So in this case, we have this area. Basically, this area is basically equal to this plus this minus this. That's basically it, right? And the equation, the major equation that we'll be using, this is parallel axis theorem, and we need to find moment inertia about x-axis. So Ix equal to Ix prime plus a dy square, right? So we need to find what is Ix prime for each of these. We have the table below, right? We can use that one. So let's take a look at the table. So if you can see, where is the triangle? Of course, this normally you should already, well, it depends whether you memorize or not, right? But okay, so for triangle, let's use a different color. Ix prime is 1 over 36 bh cube, right? For rectangular, Ix prime equal to equal to 1 over 12 BH cube. This one normally you already memorize, right? And then this one for circle is one over 4 pi r to power 4, right? Okay, let's shift this a bit because it's, yeah, it's for this one, right? And this one is here. Okay, hopefully you can still understand what's going on. Okay, so the triangle plus the rectangular minus the circle. Alright, so we have that one. So using the parallel access theorem on top as well as this Ix prime, so we can say Ix equal to, so 1 over 36. Okay, now we have to determine what is dy. So let's where's my, so this is, we have to refer back to the question. Now the centroid is here, right? X prime. Yeah, and the axis is here. So what is the distance, right? So this one, the whole thing is 9. So this one is 3 and 6, and this is what? This is 4, right? 3. Sorry, this is 4, meaning the above is 5. This is 3, so meaning that this is 2. So this distance is 2, right? The dy distance is 2 there. For this one, x, because this is x prime and x, right? X prime at the middle is at the middle, and x is just below it. So this is 4.5, so you will have 0.5, right? So the distance is 0.5. This one, x prime there, it is below the x. The distance is 2. Alright, so let's solve. We have all the information already. 1 over 36 b. Okay, let's take a look at that information. I didn't take note of that. Let's use green. So this is 6, and this height is 9, right? Height is 9. Height is 9. This is 8, and this one, the radius is 1. Alright, now we have all the information needed, inshallah. Okay, 1 over 36 b. B is 6, h is 9, then cube, and then plus a is half times 6 times 9, and then dy is 2 there. You have to have the square, right? Ix prime plus a dy square, a dy square. Alright, so plus 1 over 12, b is 8, h is 9, and then cube, plus 8 times 9, that's the area, time 0.5 square. So this minus a circle, right? So minus 1 over 4 pi r is 1 to 4, and then minus pi r square, so pi 1 square, and then dy is 2, so 2 square. So from here you can calculate 1 divided by 36 times 6 times 9 cube, plus 1 divided by 2 times 6 times 9 times 2 square. So you'll have this portion for 9 divided by 2. Double check. 1 divided by 36 times 6 times 9 cube, plus 1 divided by 2 times 6 times 9 times 2 square. 459 over 2. Okay, 1 divided by 12 times 8 times 9 cube, plus 8 times 9 times 0.5 square, plus 504. Double check. 1 divided by 12 times 8 times 9 cube, plus 8 times 9 times 0.5 square, 504. Alright, so this one minus, and then 1 divided by 4 times pi times 1 square, of course, and then pi times 1 squared times 2 square. So it becomes 17.4, 7 over 4 pi. Double check. 1 divided by 4 times pi. Oh, pi times 2 square. 17 over 4. Okay, if you add 4 over 5, 9 divided by 2 plus 4 over 4 plus minus 17 divided by 4 times pi, you get 720.148 meter to the power 4, right? Or 720.15 meter to the power 4. So we have completed question 1 completely, right? Because we have part 1 ABC. We exceed 3 minutes. The 45 minutes is until 4:15. We actually exceed 3 minutes, but that's already including all me talking and all this discussion, as well as I made the mistake there and I try to detect where the mistake is, if there's any mistake, and until I realize it takes some time. Alright, so yep, we'll move on to question 2. Of course, for question 2, another 45 minutes, so if you add that up, it will be until 5, right? Until 5. Where's my pen? So I have to write. Where's my pen? So we have until 5 p.m. there. Alright, so question number 2. Question number 2A. So we have this thing, and it says if the cable AB, so this cable AB has a tension of 100 Newton, so it's given, this tension is given. Determine the weight of the beam. So the beam, when they say the beam have a weight, so it will act at the point of center of gravity here. So there's a force of the weight downwards. And determine the support at A, so we have this roller, and at C we have this, what do you call this? I don't know what you call this, but it should be like normal reaction, right? Because you have a slot and you have like a pin, so it cannot go in this direction, right? It cannot move there. It is free to slide there, up and down, right? Point G is the center of mass for the beam. Alright, so that's the question. Question 2A. So tension, meaning that force AB is already given as 100 Newton. We need to find weight. We need to find normal reaction at A, and also normal reaction at C, right? So those are the things that we highlight. We take note what we need to do. Alright, so this is free body equilibrium problem, so it always begin with free body diagram, right? So you have basically the what is it, rod or something like that, and then you have a force in this direction. From A you have the normal direction there. This is an A. This force is known, right? This is the 100 Newton, so this is 100 Newton. And then we have weight here, right? Weight, and then we have point there, the normal reaction there, and C. What else? So in terms of the angle, this smaller angle is 15 degrees, and the bigger one is 30 degrees. The distance is, this is 0.5 meter. This is another 0.2 meter. Right, this one is not important, the 0.3 meter. What else? That's all. Okay, we can calculate. So what's the easiest? We have to do simultaneous equation, perhaps. Okay, so this maybe need to use simultaneous equation, or maybe not. Okay, let's say, because the value that we have, it is at this point. I'm thinking of whether I should, if I take moment about point A, I still have two unknown. If I take moment about this center of gravity, still two unknown, as well as at point C, still two unknown, right? Is there any summation of force? If you do summation of force X, then you have this 100 only NC, right? Because the rest only is vertical. So that is where we start. Summation of F X equal to 0, to the right as positive. So you have 100 cos 15 degrees from the 100 degrees, and then minus, okay, then what is the angle there? This angle, right? So mana ni? So this will be the 30 degrees, right? So minus NC sine 30 degrees to 0. So from there you can calculate what is NC, right? NC is 100 times cos 15 and then divide by sine 30. You get 193.185 Newton. Having that, you can, because NC you already have, then you can take summation of moment about point A equal to 0. If you take let's say clockwise as positive, so W, okay, W is clockwise, right? So W times the distance of 0.5 cos 30, right? 0.5 cos 30 degrees. The distance, right? Cos become the horizontal distance, okay? And then minus NC is already above 193.185, and then the distance is straight distance there, 0.7 to 0, right? So if you calculate this one, 193.185 times 0.7 divided by 0.5 by cos 30, so 312.299 Newton. Now we can solve for the remaining one, which is NA. So summation of Fy equal to 0, taking upwards as positive. So NA minus the weight is 312.299, and then NC cos 30 is 193 plus 193.185 cos 30 degrees equal to 0. So minus 312.299 plus 193.185 times cos 30 degrees. So bring to the other side. So N A equal to 144.99. This is correct. Oh, no wonder I forgot the 100 Newton, right? Okay, let's repeat this one. So let's take this, so that it's difficult for me to keep scrolling actually. That's the thing, because in actual paper we do not need to scroll up and down, because I can just see that, right? But Solving this one, normally it really takes the focus away, because scrolling up and down, it's just not conducive. Okay, now, so summation, summation of fy equal to 0 upwards as positive. So let's start from down here, NA. So is NA is what? NA was going to find NA, and then this 100 Newton plus 100 sine 15 degrees, and then minus W minus 312.299, and then NC plus NC, which is 193.185 cos 30 degrees equal to 0. So if you solve this, 100 times sine 15 minus 312.299 plus 193.185 times cos 30 degrees, bring to the other side. So NA equal to 119.114 Newton. So that's the answer. Basically, we have this answer, and what W as well as NA. So that's already settled everything, right? 1, 2, 3. Alright, so let's move on to question 2B. Alright, so the signboard in this figure has a weight of 80 Newton. So there's a weight here with a center of mass at G. Yeah. Determine the XYZ component of reaction at the ball and socket joint D. So this is ball and socket, and tension wire AB and AC. AB and AC. Okay, so let's do that. Okay, how to do this? Okay, so of course, what is given is the 80 Newton weight, and the rest we have to calculate, right? So we start with free body diagram, of course. So this is question 2B. So if you draw free body diagram, so basically you take this part and the cable you don't draw, you replace with the force, and then also the ball and socket, right? So basically something like this, right? Something like this. If you take together with the sign, right? Something like that, right? Okay. Should I put the force in different color? Okay, so number one, we have the weight. So the weight is going down, and the weight is 80 Newton. And then we have ball and socket at point D. Ball and socket meaning it allows for rotation, it just prevent movement, translation movement, right? So you'll have dx, dy, dz. So I take all the forces in the positive axis direction, so that it's easier when you get negative, we know what that means. And then we have force to based on the cable in two direction. So this is F AC, this is F A B, A B A C. All right. So that's the free body diagram, right? And the distance is this is 1 meter. This is another 1 meter. The rest is the dimension with respect to the forces, right? So we have to express these forces in Cartesian vector form using what we have. Alright, so for cable AB, right? So it is, you draw in that direction. Coordinate of A is 0, 2, 0. 0, 2, 2, 0, right? And then point B 1, 0, 2. So based on this, R A B is, so B minus A, Y 1I minus 2J plus 2K. RAB, the magnitude 1 square plus 2 square plus 2 square 489, square root of 9 equal to 3, right? So unit vector AB 1 over 3I minus 2 over 3J plus 2 over 3K. So FAB is just accordingly, right? So FAB equal to 1 over 3 FAB. This is the vector, right? FAB, the vector is 1 over 3 FABI minus 2 over 3 FABJ. Oop. Okay, I'm sleepy that I become like this. Plus 2 over 3 FABK. Okay, so that's for FAB. Let's do for cable FAC. So FAC, right? So from point A, which is 0 to 0, from point C, which is minus 2, 0, 1. So RAC is minus 2I plus 2J plus 1K. RAC, the magnitude is square root of 2 squared plus 2 squared plus 1 square. U is C equal to minus 2 over 3. Okay, this one is 3, right? Equal to 3 because 4, 8, 9 square root becomes 3. Minus 2 over 3I plus 2 over 3J plus 1 over 3K. So FAC equal to minus 2 over 3 FABI plus 2 over 3 FABJ plus 1 over 3 FABK. Alright, so based on the forces, so we have this unknown, this unknown, this unknown as well, but FAB and FAC is already in terms of Cartesian vector form. So we can start to calculate, right? Either using summation of forces and summation of moment. Now, for summation of forces, if you take X, you get 3 unknown. If you take Y, you get 2 unknown. If you take Z, you get 2 unknown. You take moment about point D, for example, you have 2 unknown. But if you get with respect to X, you get 2 unknown. With respect to Y, that's nothing rotation but Y. Z, also 2 unknown. What about take moment about point A? Take point A. Yeah, it's easier to take moment about point A actually in this case, right? If you take moment about point D, which is here, you have to use simultaneous equation. And my student know I'm lazy. I always want to have the shortest solution. Hence, I will take moment about point A. Right. So, summation of moment about point A, right? So now if you, because this is in vector, right? So if you use vector, so this is basically summation of R cross F, right? and this is from A, right? So we have two sets of forces, right? So three basically, because they have the weight as well. So if you have, like for example, let's take a look at this one, right? Now if you take a moment about point A, sorry, because point A, so there's the three forces about at the ball and socket. One is the weight, so two, right? So R cross F for the weight is the simple one. Is basically how to say, because R is we just take this one, right? So if we took into the matrix I, J, K, but of course that one can be used, simply use scalar, but we'll just show this one. So R becomes minus 1 J, right? So 0 minus 1 0, because it's that way. And then weight is just 0 0 minus 80, because it's just 80 Newton downwards. Alright, so this plus if you take all the forces at the ball and socket, so I, J, K, R is from A to D, so actually 0 minus 2 0, and then we have dx, dy, dz. Right, now how do I know dx, dy, dz? Because I put it all as positive here, right? If I put randomly, then this have to follow the free body diagram. Anyway, so with this in mind, can we calculate? So in this case, on the left side, I equal to 80 minus 0. Okay, I 80 minus 0 minus J 0 minus 0 plus K 0 minus 0. Alright, so here plus I, so minus 2 dz minus 0 minus J 0 minus 0 plus K 0 plus 2 dx. Right, from here, this is the whole moment, right? So basically if you add on here, you'll get 80 minus 2 dz I plus 0 J plus 2 dx K. Okay, now given that how to say, given that summation of moment equal to 0, of course meaning summation of moment about A also equal to 0, so 0 equal to 80 minus 2 dz I plus 0 J, this is not problem, plus 2 dx K. For I component, 0 equal to 80 minus 2 dz, dz equal to 40 Newton, right? For K component or Z component, because Y component or J component there's 0 there, right? So you get 2 dx equal to 0, so dx equal to 0, right? So this is already an answer. Okay, so given that this is 0 and 0, of course we do not know yet about dy, right? Dy is not known yet, right? Okay, but this 2 is known, then we can solve for the rest, right? So let me take this so that I don't need to scroll so much. So bring things down just for reference, and this one as well. Okay, and what we have here, right? Dx and dz. All right, so based on this, if you do a summation of fx equal to 0, meaning all the x component you have to add equal to 0, so from above here dx is 0, and you have 1 over 3 fab minus 2 over 3 wait, why is it fab here? Okay, that is a mistake. So these all are problematic. So this should be FAC, right? Why is it FAB? I'm not sure how many of you realize that, but hopefully you realize. But of course, even if you realize, you don't have a way to communicate with me. But yeah, at least you realize so that you know what's going on. Okay, so going back, so minus over FAC, dx is 0, so that's the only x component there. Summation of fy equal to 0, so we'll have minus 2 and 3 fab minus 2 over 3 fab plus 2 over 3 fac plus 2 over 3 fac, summation of y, dy we do not know yet. Okay, so this one is not solving, plus dy equal to 0. For z we have the value, right? So for z, summation of fz equal to 0, we have 2 over 3 fab, 2 over 3 fab, 1 over 3 fac. I'm not sure if you can tell, but I'm becoming too sleepy that it's something like micro sleeping already happening. Okay, so that's the thing. Okay, summation of fz, you have to consider the weight as well, right? Wait. Okay, yeah, this is for moment, right? For moment, this is the case, but for summation of forces, it should include the weight. The weight is 80, right? Okay, so from here you can do simultaneous equation from this first and third one, right? So if you here, okay, let's reshuffle this one. So if we bring on that side, so f a b equal to 2f ac, right? FAB equal to 2f ac. So if we plug in here, you plug in here 2 over 3 2f ac. So FAB equal to 2f ac plus 1 over 3 f ac, and this one you bring on the other side 40, so 40, right? So this one become 4 over 3 FAC plus 1 over 3 FAC equal to 40. If you add that, becomes 4 over 3, 4 over 5 over 3 FAC, 40. FAC equal to, times there, so 120 divided by 5, is it? $60. Eh, 120. What am I doing? I'm so sleepy. 120 divided by 5. 24 Newton. Now if this is 24, we have resolved FAB is what's above here, 2FAC, right? 2FAC equal to 224 equal to 48 Newton. Now having solved, okay, why am I using this color anyway? So having solved this, we can go to Fy here. So from summation of Fy equal to 0, minus 2 over 3 FAB, minus 2 over 3 FAB is 48, plus 2 over 3 FAC, (24) plus dy plus dy. Is this correct? What? Okay, why am I having this mistake? Astaghfirullahalazim. Okay, this is the worst thing that you can do in your exam, right? When you are so sleepy. Okay, so how can I make this mistake? Minus 2 minus 0 is minus 2. 0 minus 2 is negative 2. Astaghfirullahalazim. So this is Allahumma salli ala Muhammad. This is negative 2, meaning that minus 2, meaning that minus 2. Okay, I would prefer to do this kind of simulation when I'm fresh and not so sleepy like this, but I really don't have time in my schedule to have time that I can allocate, so whenever I can I have to do it, so it's unfortunate. So in this case, alright, it doesn't affect there, but it affect here, right? So alright, subhanallah. I hope from the beginning you do not just follow blindly my mistake, right? Hopefully by now when you do this, I hope you do not just watch the video, you actually try and you can detect any mistake that I can do, right? Many students in my previous video, they detect my mistakes, especially the tutorial video where I actually do it on the spot without any preparation, right? So and most of it is when I'm sleepy as well, so it's just filled with the method normally is correct, but the number normally it's a mistake. 48, so dy is 48 Newton. Subhanallah. Okay, so we have another 5 minutes before 5 p.m. and then we have question 4c, right? So we have solved the, okay, what is we have solved? Well, we have solved dx, dz, and bottom here dy, and then these two forces, right? 24 and 48. Alright, so let's go for question 2c. Okay, what is the question? MashaAllah. What will happen if the signboard, what will happen to the signboard if a force with magnitude 100 Newton is exerted at G in the upward direction? This is question 2c, right? Now, if a force is exerted, okay, so let's see, upwards here, because what we have is basically what we have is 80 Newton downwards, right? So if we put 100 Newton upwards, actually the net force in the Z will be upwards positive, right? So basically, we can indicate that basically either the support no longer support or hold the sign board in place, or basically is no longer static, right? Why? Because basically no support that prevent rotation, basically rotation upwards, right? Because it will actually rotate about at least about X, but the rest is depend on all the other forces, right? But that's already beyond statics because it's already moving, because no support actually counter the moment. Alright, so that's just before 5 p.m. Oh, mashallah. Okay, so afterwards at 5 p.m. we'll take a look at question 3. Alright, let's take a look at question 3. Alright, so question 3 is based on this thing. We have a 20 Newton force. Okay, let's just. Alright, so 20 Newton at the handle there. Determine the clamping force exerted on wire at B. So there's wire at B here, and the magnitude and direction of resultant force on pin A. So there's a pin here. We want to find the reaction there. And part B is internal loading. So we'll do one by one, of course. Let's do part A then. Okay. Okay, bismillah. Question 3A. Right, so if you want to solve this, you have to draw the free body diagram, right? So basically something like this, something like that, right? Something like that. And the pad, the other one is the bottom one, right? So we have okay, the shape is weird, but yeah, you get the idea, right? So let's zoom out a bit. Anyway, never mind, because I want to see both, but you know, the screen is not enough. Okay, so because we have force here, which is 20 Newton, and the same here, right? This is 20 Newton. Boleh lah. Okay, and then we have at the middle here, we have a corresponding pin A here. So let's just assume AX AY, so it will be corresponding AY AX, right? Okay, and then here we have, because if you consider the the wire B, right? It is being clamped. So obviously, because this is the bottom one, right? So it correspondingly it will be like this, right? So let's call it NB. So NB, this is NB. Now in this case it's actually identical, right? These two, because it doesn't indicate anything about, because it's just symmetrical, so we can just use one of the two, right? So if I label this as this is my free body diagram 1 and 2, we can use any one, the answer will just be the same. So what we need is, okay, this is the distance until this point is 120 Newton, 120 millimeter, and then here is 40 millimeter. Alright, so okay, then we have to scroll, right? Okay, never mind, because I want to see, side by side when I do it. But okay, if we do okay, I'll use this side if this is possible. Now straightforward, if we want to find NB, right? So we do, okay, using free body diagram 1, right? This one. So taking summation of moment about point A equal to 0, and let's consider counterclockwise as positive. So you'll get NB times 40 if you use in millimeter, and then minus 20 times 120 equal to 0, right? This is counterclockwise and this is clockwise, right? So NB, you can calculate to be 20 times 120 divided by 40, 60 Newton. Right, and the question actually, okay, we haven't taken note what the question want, right? So the question say determine the force, which is NB, and the magnitude of direction resultant at pin A. So meaning that we have to find AX and AY as well, right? So with the same free body diagram, so if you do summation of Fx equal to 0, then you have minus AX equal to 0, or AX equal to 0, right? Because there's no other horizontal force. If you do summation of Fy equal to 0, taking upwards as positive, so okay, in this case, because everything is downward, so minus 20 minus AY, we are using still free body diagram 1, right? And minus NB, which is 60 equal to 0. So AY will be minus 80 Newton, right? Meaning opposite direction, right? Meaning opposite direction. So that's the answer, AX, AY, and NB. Now opposite direction meaning that for the free body diagram here it will be upwards, but for free body diagram downwards, number 2, it will be downwards. Alright, so that's part A, right? We have covered all, right? Part A. Determine the clamping force. We have magnitude and direction of resultant force. Okay. Now going to question 3B. Okay, let's bring it down. What? Why? Why can't I? Oh, I haven't select. Okay, question 3B is internal loading. Internal loading at point D, right? Through point D. Now there's two ways for calculating this. because point D is here, and it involves this free body diagram actually. So if I, well, let's copy this. Now basically what we do is, let's use this color, because point D is basically here, right? Basically here, right? And there's an angle there of 30 degrees. You cut through that angle, so you either use the bottom half or upper half there, right? But the easier one is using this one, right? Because one is easier, there's not much force, and second, it is not affected by all of this value, where this is what we have calculated, and if we have calculated wrong, we use that value, it will be wrong as well, right? So might as well use the left side. So let's use that left side first, and if we have time, we will take a look back at whether we can try to use on the right side to see the answer is the same or not. It should be the same. That exercise is just for this exercise, right? In the exam, why you waste that time? Okay. Wait. What? All right. So meaning that what? Meaning that it will be something like that, and then you cut there, right? Oops. Something like that. Oops. Okay lah. So 20 Newton is here, and this is point D, right? So we have that one shear moment, right? This is point D, right? We call D, right? So ND MD VD. Now in terms of the direction, because meaning this slanting at 30 degrees, and you have the option whether you want to use horizontal and vertical, but that will be meaning simultaneous equation that I don't like. So I prefer to use, basically, let's say this is my x-axis, this is my y-axis, right? Basically, so that V is in x-axis and N is in y-axis. But in that case, you have to resolve. Where's my name? You have to resolve this 20 Newton based on this 30 degrees, right? So meaning that the angle here, this is 30 degrees, right? Between the vertical and that x-axis, right? The same, right? So if we do this, and I'm to calculate on this side here based on this free body diagram, right? Okay, straight away, right? Summation of fx equal to 0. So taking this direction as positive, right? Along VD, right? So we have VD positive, and then 20 is negative because it's on that side. So minus 20 cos 30 degrees equal to 0. So VD equal to 20 times cos 30, 17.32, right? Or if we want to take the whole thing, 3205 Newton. If we need to reuse it, then that's more accurate. Okay, summation of Fy equal to 0, taking along that one positive y. So we have ND. This one will be positive as well, right? So plus 20 sine 30 degrees to 0. So ND will be negative, right? Negative 20 times sine 6.8404. Is that correct? What am I doing? Wait, I key in the wrong number. Masya Allah. No wonder. Times sine 30. Okay, so when you're sleepy, you even key in the wrong thing. In the exam, if that happened, then that's like the worst case scenario that you ever. So don't. Make sure you have enough sleep before the exam. 10 Newton, yeah. Okay, and next is moment. Okay, interesting. So I'm using this side so that I can see the diagram. Summation of moment about point D equal to 0. Not. Yeah. Taking counterclockwise as positive to be the same. So MD and then minus. Okay, how to do this? What is the distance? What is the distance? Let's see the question. Okay, the distance is 80. The horizontal distance is 80, right? The horizontal distance is 80. Meaning that from this point here, horizontal is 80 mm to the exact point here, actually, right? To the point here, right? So okay, mainly I don't need to resolve because this is straightforward vertical perpendicular, right? So straight away this is clockwise. Okay, so minus 20 times 80 millimeter. So MD equal to 1600 Newton millimeter, right? Or if you use meter, then if you convert, it becomes 1.6 Newton meter, right? So that's the answer. All right. So that's the answer. We have solved question 3B. Okay, question 3 is very short, right? Because it's already over, right? Okay, so you get 25 marks just for that. I think this question is not difficult and it doesn't take long. It's just if you don't understand, then you'll just waste the mark, right? So make sure you really understand. This question is not difficult. As you can see, the calculation, the whole calculation for 25 marks, for quarter of the final exam marks, is just that, right? So it's simple, but it tests your understanding. Okay, just for the sake of meaning, if you want to choose on this side, right? on the right side, what will happen? So let's again, I have to copy this because otherwise I'll be scrolling again and again. If you take on the right side, if you don't need to do this, but if you take on the right side, so your free body diagram will basically be like something like that, right? And then it's slanting there, so you'll have N, you have V, and you have M, right? So MD, VD, and D, and then this is the 30 degrees, right? Correct. Let's see the original diagram. That's slanting, right? So it's something like that, where you have, the thing is, you have A here, right? You have point A, which, okay, and B here, right? Where NB already have determined to be 60 Newton, and AX is 0, right? Where's my mouse? AX is 0, AY is 80. So AX 0, AY, yeah, we use the bottom one, so it's opposite. So AY downwards. So downwards 80 Newton, right? AX 0. And then in terms of the distance, in terms of the distance, okay, this distance is 40. Okay, this distance is 40 mm. this distance is basically the whole 120 minus 80, right? To get this one, we can 40 elsewhere, right? 40. Okay, let's try this one. It should give you the same answer, right? It should. All right, so if you do summation, okay, let's again, because then to have where is it, so that calculation is easier. So I'll take something like this. Okay, along that one, this is x, this is y, right? Along that one. So meaning that there will be 30 degrees here, right? And meaning that this is the 30 degrees, right? To relate to that axis. Okay, so if you do summation of fx equal to 0, now vd will be the negative side, so negative vd, and then we have 80 to positive, so plus 80 cos 30 degrees, and 60 is negative, so negative 60 cos 30 degrees equal to 0. So vd equal to 80 times cos 30 minus 60 times cos 30, 17.3205 Newton. It should be the same, right? 17.3205. Okay, right. So if you do summation of fy equal to 0, okay, summation of x just now positive that way, right? So summation of fy positive that way, right? So you get minus nd because it's negative. 80 also negative, so minus 80 sine 30, and then plus 60 sine 30 equal to 0. So nd equal to minus 80 times sine 30 plus 60 times sine 30 minus 10 Newton. Again the same, right? Okay, you can continue with md. Okay, let's continue, we have time, right? I become so lazy now. Okay, summation of md equal to 0. Let's consider counterclockwise as positive. Sorry, this is clockwise. Okay, my mind is already so slow. This is clockwise. Okay, so md, so for 80 is also positive, so plus 80 times 40 millimeter, and then minus 60 times 80 millimeter equal to 0. So if you calculate this, md 80 times 40 minus 60 times 80 minus 120. Okay, and then you bring at the other side, right? So 1600 Newton millimeter, or 1.6 Newton meter, right? So the answer will be the same if you take either side. Of course, one will be shorter than the other, right? So if you can see here, if I zoom out, right? So this one is shorter than this one, a bit shorter. I mean, the step is the same, the number of steps is the same, but the calculation, actually the individual calculation, is this one a bit longer, and it depends on the value that we have earlier, right? All right, so that's question 3a and b. Now we go to question 4. All right, question 4. Refer to the structure shown in figure 6. Two identical boxes A and B have the same mass, 100 kg, and stacked as shown. Okay, so both have the same mass, meaning each have 100 kg. 100 kg. All right. Now, what are the four possibilities that can happen if P is large enough to cause a motion, right? So this force P is pushing, so what are the four possibilities, right? So let's just take a look at this. And question 4A. Question 4A. Okay. Four possibilities. Number one. Okay, let's see the diagram. Okay. Number one, if I hope you understand the concept by now, right? Of course, if you are studying for final exam, you should know already what are the possibilities. One is that block A slip, right, or move, right? This is between slip and tip, right? So slip meaning that the friction at the surface is already at the maximum, and you keep pushing and it will move, right? So basically, this block will just move. That's number one. Number two, block A tip. So this is if the friction can still sustain, but the normal reaction is already at the end, so it will tip over, right? It will tip over. Alright, so number three, block B slip, right? Meaning that, so together with A, right? Meaning that because A is on top of it, so the slip, Allahu Akbar. Okay, what happened? Okay, so the slip happened at the bottom, right? So meaning block A and block B and A. So it move here, so it brings together the block, right? But if you read it, block B slip together with A, it doesn't sound. Anyway, avoid that. That's just. And then another one is block B tip. Of course, together with A, meaning that, of course, if it tipping, of course, what is on top of it is tipping together, right? Right. So that's the four possibilities. Now, in term of the understanding, right? In term of the understanding, I think this should be in your lecture. You have covered this because if you are already preparing for final exam, you should not. You should already understand this, but just as illustration, right? So because we have to block the storyline, right? Now, for each block, right? Because normally there's just that, right? Okay, let's make it bigger. So for one block, right? Under normal circumstances, it will have just the normal, the weight and the normal reaction counter it, so it's static. When you apply a certain force, then the friction will counter, so that it will be static. But static require both force and moment to be equilibrium, right? Equal to zero. Now, in terms of moment now, it's no longer equilibrium because this force and the friction, right, creates rotation like that. So there must be something that counter this to make it equilibrium. That is where the normal reaction here, right, this normal reaction here is shifted basically there, so that you have the weight going down and the normal reaction is on the right going up, so you produce that rotation, right? So if this force goes up further, meaning the value is higher, friction will be higher, right, to counter summation of fx. That means this moment will be higher because of the value of the force. Mean this have to counter higher, so the distance will become higher until it reach at this distance, right? So anyone can happen first, right? If this friction is already at the max, which is equal to mu Sn, then it can no longer further increase the friction, and then if you push further, this will move. Or if the maximum is not yet achieved, but this is already at the end, then this cannot sustain this one, so it will tip over, right? So that's basically what it is. Now that also, because we have two blocks, so it have a chain reaction, right? So basically, because what happened in this block create this friction, but if you draw the bottom block, this friction have this equivalent force, which why it's trigger also this friction, right? And also it trigger the story of the normal reaction, etc. So that's how it happened, that in the end one of this will happen, right? One of this will happen. All right, so that's the story. We have taken several time for the story. Let's see if we can still. All right, so question 4a is finished. Let's go to question 4b. If the coefficient of friction between box is UAB is 0.8, meaning between box, meaning that between A and B, and between box and the ground is 0.5, meaning that this is 0.5. Determine the maximum force P required to cause impending motion. So impending motion is just the moment where it is about to move, right? That's the maximum it can go. Any additional force is motion will happen, right? So basically impending motion is that point. What will happen if force P exceed that value? So what will happen, meaning that one of the four possibilities, right? Because only one of the four will happen actually. Right, so going here, question 4b, right? Question 4b. So let's use, okay, wait. Okay, so what is given is mu AB is 0.8. Mu AB is 0.8. Just so not to forget, mu B at the bottom is 0.5. Alright, and weight is 100, right? Just before, both have weight of 100, right? 100 kg. Alright, so a mass 100 kg for both. Alright, so if we do one by one, based on the possibility, okay, the idea is like this. If you have learned also tipping and slipping, right? So either you assume and then you know analyze whether the assumption is correct or not. For example, assume this and then you calculate and then you check whether the assumption is correct or not. That's one way of it. But when you have multiple options like this, one way is just calculate the force to cause each of one. So the smallest one will be the one that trigger the motion first, right? So we'll consider the four possibilities here, right? So the first one, I'm just going to copy this one. So when block A slip, right? When block A slip, so what will happen in terms of the free body diagram? The free body diagram will be for block A. This is just block A. So we have 100 times 9.81 Newton. We have the force P there. So we have the normal reaction somewhere there. There is still the middle, because when we said it slipped first, meaning that it will not reach the end yet, right? So this will be N and A for block A, and then this one friction is already reached the maximum, right? If you assume slip first, then it will be mu N, right? Mu is 0.8, so this will be 0.8 and A. Alright, so that's it, right? So with this, how to calculate is simple. So summation of Fy equal to 0. Now, if you just want to calculate P, it's simple because you do not need to calculate for moment. But if you want to use checking, then you have to calculate for moment, and then you have to calculate the distance, right? But here it's just straightforward because everything is vertical and horizontal. So taking positive upwards, so you have NA minus 100 times 9.81 equal to 0, and A equal to 981 Newton, right? Just right. And then summation of fx equal to 0, taking positive to the right, so p minus 0.8 and a is 981 equal to 0, so p equal to 0.8 times 981, 784.8 Newton. That's scenario number 1. Let's go for scenario number 2, which is block A tip. So for block A tip, so the difference is for this block, right, where obviously the weight is still the same, 100 times 9.81 Newton, and the force is still the same there. But this normal reaction is already assumed, or it has already reached that edge because we assume tip first, right? And the friction is not known, but it is not yet at the maximum, so it's a random F. Right, so how do we solve this one? Okay, in this case we have to use a moment then, right? Because we have 3 unknown there, and we cannot solve using x and y. So then we have to have the distance, so this is 1.5 meter, and the height for this particular height is, because this 5 minus 4 is 1 meter, right? This is 1 meter. So to make it easy, let's consider this point, because we have A, B, right? What point do we want to use? Let's say point C. Let's name this point C. Then summation of moment about point C equal to 0 if you take counterclockwise as positive, for example. So P times 1 meter counterclockwise, and then minus 100 times 9.81, that's the force, time the distance of 1.5 meter equal to 0. If you calculate that one, P equal to 100 times 9.81 times 1.5 becomes 1471.5 Newton. Now this force seems excessive, right? Because it's so much, but it's logical because if you look at the this scenario, right, and just look the free body diagram as well, the force to create the moment must be so big, the force, because the distance is so small, meaning that if you have, because if you push here to tip it, it's easier, right? It requires less. But if you push here to make it tip, it must require more, right? And normally it slip first, and hence you can see here between the two options, this one will happen first. But we do not solve another two yet, so we cannot say anything yet. So let's go with this one next. So this is block B slip together, of course, with A, because A is on top of it. So meaning what? Meaning that in terms of the free body diagram, oops, okay, ignore the yeah. So it's actually both together, right? So we have 100 times 9.81 Newton here for block A, and also 100 times 9.81 Newton here for block B. That's the weight. The force is here, right? So here, because we consider that what the movement is here first, right? So meaning that between this it's still attached. So this is slip, right? So N is still in the middle, so let's consider this NB, and the friction will be the maximum, which is 0. What is mu? 0.5, right? So here 0.5 and B. Consider it as such. So from there we can calculate. So summation of f y equal to 0, taking upwards as positive. So NB minus 100 times 9.81 minus 100 times 9.81 equal to 0. So NB equal to 1962, and then summation of fx equal to 0, taking positive to the right. So p minus 0.5 and b is 1962 equal to 0. So p equal to 981 Newton. Alright. Okay, and we have another possibility, which is the last one. Of course, in the real exam, you don't have copy paste, right? Of course, if you, I'm talking about writing on the, use pen on the paper, right? Okay, block B tip together with E. So this means that the block are still together, right? So the weight as just now, 100 times 9.81 Newton, 100 times 9.81 Newton. Oops. The force is still at this place, and the distance is 0.5, right? From the question. 5, sorry, 5 meter. Is it 5 meter? Yes. And then the friction. No, so when we strip, then normal is already at the edge and the friction is unknown, right? F. So again we will use moment. So this one is 1.5 meter. Now let's consider this. Just now we label it what? C, so let's label it D. So summation of moment about point D equal to 0 if we take counterclockwise as positive. So P times 5 for the distance, and what else? Okay, so about point D, this is D, not O, D. Okay, so it's clockwise, minus 100 times 9.81 times the distance of 1.5, and then we have another one's identical, 100 times 9.81 times 1.5. Is there anything else? No. So we only have 4 forces, 1, 2, 3 forces that produce moment about point D. So meaning that P equal to, let's calculate that, minus 100 times 9.81 times 1.5, and then divide by 5. So we get, bring to the other side, 588.6 Newton. Right? Okay, so we have compute all the 4, but these are the 4 possibilities. But as you increase the force P, one of these will be reached first, and then that will happen, right? So if you compare 784, 1000 plus 1000 plus, 981 and 588. So the minimum, so the smallest P between the 4 is 588.6 Newton when both tip, right, or tip at B, meaning B tip together with A, right? So the question is what? The question is, what is the question? minimum force required to cause impending motion. So minimum force P for impending motion is 588.6 Newton. Right, so that's the answer. And what will happen if P exceed 588.6 Newton, block B will tip over together. Okay, mengarang pula with block A. So that's the answer for part B, right? Now, question part C. Question for C. If coefficient for static friction of the between the box becomes 0.2, so if mu AB becomes 0.2, what will happen? Will it be harder to cause motion for box A? Will it be harder to cause motion for A? Okay, now the original one is where? The original one is 0.8. So originally mu AB is 0.8. So now it reduced, right? So what will happen? So if for that to happen, what was going on? Okay, apa dah tadi? Now, so that means that mu AB reduced, right? When mu AB reduced, okay, if you can see is in this scenario, right? This is this particular scenario. This is exactly particular scenario. This is just for illustration, right? So originally is 0.8. So if this actually becomes 0.2, meaning that the whole thing will reduce, right? The maximum friction will reduce. Meaning what? Meaning it will become easier for it to slide because the minimum friction that can occur there becomes much less. So you just push, the friction can go only to a certain lower value. It's easier to move, right? So the question say, will it be harder to move? So no, it will not be harder to cause motion for box A. In fact, the maximum friction will become less, so easier to move. Right, so it's exactly the end of the paper. Yep. Okay, so that's it. We have completed all the 4 questions, and the total time 2:30, 4:30, 5:30, 2 hours and 20 minutes. So you should have another 40 minutes to check, double check, and triple check all of the questions, right? And this 2 hours and 20 minutes, we actually do it with all the conversation, and I actually solve more than needed for one of the question. I try to solve both to compare. You don't actually need that for the final exam, etc. So normally, if you are quite well prepared, normally it's shouldn't be any problem to solve every question in the final exam for 2 hours in a 3-hour exam. That's normally how it is. So you should have a buffer time that is enough for you to double check and triple check, inshallah. Alright, so I think that's it for this video. I actually have to pray asar. Yeah, hopefully this help. And if you actually watch throughout, you will notice that there are moments where I make some mistake. I didn't realize for certain mistakes, and I have to, go back and trace the mistake, etc. So yeah, there are several things that's a real time what happened, because I'm doing this live, not live, but real time, right? It's not like I'm just following a answer scheme, etc. So that's how we do in the final exam or in the exam room, right? We just process things, but just like you saw me, that those are the type of things that, when we are not focused, etc., mistake like that can happen. We, negative, and then we will go to the next line, the negative missed, and the whole thing is affected. For example, what is the other mistake that I did? I didn't, one of the force, when I do summation of forces, I didn't take care of that one. Also some mistake. So make sure when you see that, remember that, oh, that kind of mistake can happen. Double check, triple check, right? Double check, triple check in your exam. All right, because in the exam, at the end of the day, in the exam, your marks is not just based on what you understand. It's based on whatever you understand, you put on paper without mistake. That's the thing, right? So sometimes you understand everything, but somehow mistake happen, you lose a lot of mark. Avoid that. Be prepared, be fresh, not be sleepy, and check, double check, and triple check. With that, inshallah, hopefully, Allah will make it easy for you, inshallah. Wallahu a'lam. Hopefully this help, and yep, see you next time.